Hello again, Algebra 2 students. We're back into our complex number syllabus, and we are on our last lesson in Tier 3, Lesson 6. And we are going to check this off our booklet. All right, so we're going to finding imaginary solutions with the quadratic formula. We can use the discriminant to quickly identify if a quadratic equation has complex solutions or real solutions. If you recall that if it's got positive discriminant, again, the discriminant is just figuring out the values of b squared minus 4ac. And if that number is positive, then the solutions are real. And if that number is negative, then the solutions are imaginary. So what we're going to do is we're going to decipher what the discriminant is in these two equations and then find our solutions. Let's start with my A. My A is negative 3, my B is 1, and my C is negative 3. So, using my discriminant, I have 1 squared minus 4 times negative 3 times negative 3. 1 minus 36 gives me negative 35. So I definitely am going to have two imaginary solutions. Let's scroll down here. And the only way to find imaginary solutions really is to use the quadratic formula. So let's go the opposite of b, which is 1 plus or minus the square root of 1 squared minus 4 times negative 3 times negative 3. There's our discriminant all over 2a, and our a is negative 3. So we know that this is negative 1 plus or minus the square root. We figured the discriminant out already up here, so we already know what's under that radical, which is negative 35 all over negative 6. So there are two imaginary solutions, and we could actually, if we really wanted to, we could simplify it a little bit more by going negative 1 plus or minus the square root of negative 1 times the square root of 35 all over negative 6, which would give us a positive 1 plus or minus I times the square root of 35 all over positive 6. And those are our imaginary solutions for that quadratic equation. For this quadratic equation, our A equals 1, our B equals negative 6, our C equals negative 5. So if we use our discriminant, we have negative 6 squared minus 4 times 1 times negative 5, which gives us 36, plus 20, which gives us 56. So we know it's positive, so we have two real solutions. And again, using the quadratic formula, we go the opposite of b, which our b is negative 6, so we're going to go 6 plus or minus the square root of negative 6 squared minus 4 times 1 times negative 5 all over 2 times 1. And again, this is the discriminant that we already figured out, so we know that it's 6 plus or minus the square root of 56 all over 2. I just drew out the prime factorization of 56 so that we could look for pairs, and we found one pair, so we could pop that 2 out very easily. So this would simplify to 6 plus or minus 2 times the square root of 14 all over 2, which simplifies to 3 plus or minus square root of 14.